Right, so here we are, the Binomial Theorem 5.4. So yes, we're going to take a second. You might want to remember what we did with Pascal's triangle because we're going to be discussing it, as you can see on the left. On the right, we're going to discuss the summation notation. There's a video attached at the end to explain that a little bit more. Basically, it's just sum of terms with a counter so that one value changes and we keep up adding all those sums. Just recall, a binomial is a polynomial expression with two terms, so x plus y, a minus b, negative 3x squared minus 4x, or 4y to the cubed. Those are all binomials because they have two terms or two numbers. Okay, so today we're going to look at the expansion of a plus b. So think about a plus b to the 0, obviously equals 1, a plus b to the 1, a plus b. A plus b all squared, a squared plus 2ab plus b squared. A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. 3 plus a plus b to the fourth is that, and a plus b to the fifth is that. So take a second, look at our values here, think about them. How do they compare to Pascal's triangle? You might want to pause, take a couple seconds, think about it. Right, so what hopefully did you notice? The coefficients of the expansions, the corresponding row in Pascal's triangle. So basically the expansions were the a squared plus b squared, all those things, or a squared plus 2ab plus b squared would be the second row of Pascal's triangle, 1, 2, 1. The exponents of each term have the sum equal to the row number. So when we got down to the cubes, a squared plus b, 2 plus 1 is 3. So it's the third row. Exponents of a decrease while the exponents of b increase. So hopefully you notice that as the a's went got lower values and the b's got higher values. So take a second, think about what a plus b to the 6th will be. Well, hopefully you got something like this. Okay, so here you notice that coefficients add up to 6, or exponents add up to 6. Coefficients are the row 6 of Pascal's triangle. Okay. The a's are decreasing while the b exponents are increasing. Right. So if we think about Pascal's triangle, remember Pascal's theorem that any one term in Pascal's triangle is equal to the two terms above it. Okay, we can also write that using combination notation. NCR equals N1CR minus 1 plus N minus 1 CR. So this would kind of give us the idea of the term. These will actually start giving us the values. Okay. So if we want to, we could write row 10, term 2. We can write that using combinations as well. Row 9 term 1 plus row 9 term 2. And if you want to, you can take a second, punch it in your calculator, actually get out a value. So you don't need to know the row above it, you just need to know how to use combinations. Right. The binomial theorem comes from combining our investigation into the expansion of a plus b and Pascal's theorem. Okay, so we're going to talk a little bit more about this. If you want to learn more about summation notation, which is this little symbol here, I suggest watching this video. It'll probably be about 10 minutes. It's worthwhile. It's kind of interesting. It's a good explanation, better than I could do. And we'll talk a little bit more about how this expansion works and its other interesting features. So here's some homework to do. Let's do those questions. We'll talk about those, and then we'll look further at the expansion of the binomial theorem.